Today's topic is Brewester's law. The Scottish physicist Sir David Brewester discovered that for a certain angle of incidence, monochromatic light was 100% polarized upon reflection. The refracted beam was partially polarized, but the reflected beam was completely polarized and polarized parallel to the reflecting surface. Furthermore, he noticed that at this angle of incidence, the reflected and refracted beams were perpendicular to each other. So let us consider this as a glass plate which is having some refractive index mu, and this is air. So this is nothing but the interface between the air and glass. Then with this as a normal, here a beam of monochromatic light, which is unpolarized beam of light, is incident at some angle of incidence, say theta. So as it is unpolarized beam of light, you know that the electric field vector in case of unpolarized beam of light, it vibrates in all possible directions, and therefore here both the components of light, like parallel and perpendicular component, both are present simultaneously. So lines as well as dots both are present simultaneously. It means that this is an unpolarized beam of light. Then you know the symbol for representation of a plane polarized light. It can be shown by either lines or it can be shown by dots. It indicates that light which vibrates in only one plane, that is in this case of a light, the electric field vector, it vibrates in only one plane, and therefore it is known as a plane polarized light. So here we can obtain a polarized light by reflection. So when an unpolarized beam of light is incident at any angle of incidence on any transparent surface, then the reflected beam is just polarized. You can say that it is partially polarized. But if the angle of incidence for the unpolarized beam of light is equal to the polarizing angle, which is a particular angle known as a specific angle or polarizing angle, or sometimes it is also known as a Brewester's angle. So when an unpolarized beam of light is incident onto the transparent surface at the polarizing angle IP, then it has been found that the reflected beam is completely plane polarized while the refracted beam is partially plane polarized. So as it is partially plane polarized, so here again both the components are shown which are present simultaneously, that is perpendicular and parallel component. While here there is only one of the component is present, so it is completely plane polarized. Then further, this Brewester, as I said earlier, that he observed that the reflected and refracted beams, they are always at right angles to one another. So as they are always at right angles to one another, and hence from the Snell's law we know that refractive index of medium mu is equal to sin I upon sin r, where I is the angle of incidence and r is the angle of refraction. So here the angle of incidence is, say, theta b. So our formula becomes mu is equal to sin of theta b upon sin of r. R is angle of refraction. So here his r is the angle of refraction, and which is no doubt here you know that angle of reflection is equal to the angle of incidence. So this angle is equal to again IP. This angle is, say, RP, which is angle of refraction. So from the geometry of the figure, if this angle is 90, so you know that IP plus RP will be equal to 90 degree. So using this, we can write sin of theta b, where theta b is the angle of incidence, or you can call it as a polarizing angle IP. So sin theta b upon sin of r will be equal to pi by 2, which is 90 minus theta b. And therefore this mu will be equal to sin of theta b divided by sin pi by 2 minus theta b will be equal to cos of theta b. So sin theta b upon cos theta b will be equal to tan theta b, and that is equal to mu, or you can call this angle theta b or represent this theta b as IP in order to indicate this as polarizing angle. Then so what is the Brewester's law is? The Brewester's law, one of the statement of Brewester's law is whenever an unpolarized beam of light is incident at the polarizing angle IP, then the reflected beam is found to be completely plane polarized and refracted beam is found to be partially plane polarized, and they are always at right angles to one another. This is one of the statement of Brewester's law. And the other statement of the Brewester's law is the tangent of the polarizing angle IP is numerically equal to the refractive index of the medium. So if you know what is the refractive index of the medium mu, then you can calculate the polarizing angle IP by taking tan inverse of this mu, and therefore if you know the polarizing angle IP, you can calculate the refractive index mu, or if you know the refractive index mu, then you can calculate the polarizing angle IP. So from this equation, it is also clear that as refractive index mu is different for each and every material, and therefore polarizing angle IP is also different for different materials. It is not same for all the materials. Then polarizing angle IP in case of glass is 57 degrees. And that's why here in this figure, here it is shown that if the angle of polarization is 57 degrees for an unpolarized beam of light, then the reflected beam is found to be completely plane polarized. Again, this angle of reflection is equal to the angle of incidence, which is 57 degrees shown over here, and the refracted beam is refracted at an angle of 33 degrees, so that this 57 plus 33 is equal to 90 degree. It means that reflected and refracted beams, they are always at right angles to one another. So now you are clear about the fact that the tangent of the polarizing angle IP is numerically equal to the refractive index of the medium. So if you have given the refractive index mu, you can calculate polarizing angle IP. If you have given IP, you can calculate the refractive index mu. As refractive index mu is different for different substances, polarizing angle IP is also different for different substances. Now when you come for the next class, come up with the solution of these two questions. The first question is, at what angle light should be incident on a glass plate with the refractive index mu, which is 1.5697, to get a plane polarized light by reflection. And the second question is, a ray of light is incident on the surface of a glass plate at polarizing angle IP, which is 60 degree. So calculate the refractive index mu of the glass plate. So let us just come out with the solutions of these two questions in the next class as an assignment. Here in question 1, you have given the refractive index mu and you have to calculate the polarizing angle IP, while in the next question you have given the polarizing angle IP and you have to calculate the refractive index mu.